I'm Satya, Assistant Professor, Department of Computer Science from KCS Kosinagar College of Arts and Science. Now we are going to see some important topics in virtual machines and system design and implementation of operating system. What do you mean by virtual machines? A virtual machine takes a layered approach to the logical conclusion. It treats the hardware and operating system kernel as though they were all hardware. A virtual machine provides an interface identically to the underlying bare hardware. The operating system creates illusion of multiple processors, each executing on its own processor with its own virtual memory. Here, the operating system as well as hardware are separated only. OS is a program, it's not a software or hardware. But in virtual machine, the OS is treated as a hardware. It's make the user to think the OS and the hardware combined together for executing a program. And there may be a single processor only executing the programming. At the time, the virtual machine create an illusion that each and every program has separate CPU for executing its own program, and each and every program has its own memory. Likewise, each and every resources are allocated to the user separately for the execution. This is an illusion. It's created only by the virtual machine. The resources of the physical computer are shared to create the virtual machines. That is CPU scheduling, create the appearance that users have their own processor. And spooling as well as the file system can provide the virtual code readers and virtual line printer. A normal user time sharing interval systems serves the virtual machine's operating console. This is the virtual machine system models. If it is a non-virtual machine, means the processor is act as a single one. Here, basically we are having the hardware in the layer 0, and in the layer 1 we are having the kernel. Kernel means the operating system, and above the operating system there are so many processes, application programs, system programs that may be in execution. So in non-virtual machine, the it's considered as a single processor, single operating system is there, it's executing the program. But in virtual machine, between the hardware as well as the operating system, we are having the virtual machine. Virtual machine is also a program only. Okay, it creates an illusion that each and every process running in the CPU may think that we are having a separate operating system so that the work is done without interruption and very fastly. What are the advantage as well as disadvantage of the virtual machine? The virtual machine concept provides complete protection of the system resources since each virtual machine is isolated from other virtual machines. This isolation, however, permits no direct sharing of the resources. A virtual machine is a perfect vehicle for the operating system research and the development. System development is done on the virtual machine instead of on a physical machine, and so does not disturb the normal system operation. The virtual machine concept is difficult to implement due to the effort required to provide an exact duplicate to the underlying machines. Here, all are the advantages only. The only disadvantage is that it's very difficult to implement. What are the system design goals? System means the operating system only. The operating system is designed for some goals. Here there are two types of goals. One is the user goals as well as the system goals. This is the point of view only. In user point of view, the goals get different. In system point of view, the goals get different. In user point of view, the operating system should be convenient for the use and easy to learn, reliable, safe as well as the fast. But in system point of view, the operating system is easy to design, implement, and maintain, as well as it's flexible, reliable, error-free, and it's also efficient one. The mechanism and policies in operating systems are the mechanisms determine how to do something, policies decide what will be done. The separation of policy from mechanism is a very important principle. It allows maximum flexibility if policy decisions are to be changed later. The system implementation. System means the operating systems. The implementation is done by. In traditionally, the operating system is implemented in written assembly language only. The operating systems can now be written in higher level languages. The C languages are used for the operating system development. More or less, the Unix as well as the Linux operating systems are designed in the C languages only. The code written in high level languages is can be written faster. It's also more compact also, and is also easily understand and debugging. If any modification done in the further means, if it is written in higher level languages, then it may be easier. The operating system is easier to port, move from one place to another place if it is written in higher language. If it is written in assembly language means the user cannot be understand, only the machine can be understand. So it is very tough to write. Final thing is the system generation. The generation of the operating system may be vary from the starting to till date. The operating systems are designed to run on any of the class of machines. The system must be configured for each specific computer site. System generation is a sysgen program, obtains information concerning the specific configuration of the hardware system. Booting. During the time of starting a computer, the program is loading into the system, that is loading the kernel. Bootstrap program. Code stored in the ROM, that is read-only memory, that is able to locate the kernel, load into the memory, and it starts the execution. Thanks to all.